There's something humbling about looking up at the night sky. The same stars that have guided humanity for thousands of years still shine down on us today. But what if I told you those stars weren't just admired by ancient civilizations? They were blueprints, hidden in the ruins of temples, pyramids, and forgotten cities, are clues to a breathtaking truth. Our ancestors didn't just watch the heavens, they built their world in perfect harmony with them. These were the forgotten architects of the sky, master builders who encoded celestial knowledge into stone, aligning entire civilizations with the cosmos. Why would cultures separated by oceans and centuries share this same obsession with the stars? And what did they know that we've only begun to rediscover? Picture this, a society without satellites, telescopes, or modern science, yet capable of tracking planetary movements with jaw-dropping precision. From the towering pyramids of Giza, aligned to the cardinal points with near-impossible accuracy, to the Mayan observatories where priests predicted eclipses centuries in advance, these structures weren't just feats of engineering, they were celestial maps. The ancients saw the universe as a living, interconnected force, and their buildings were bridges between earth and sky. Temples became cosmic calendars, solstice markers doubled as divine messengers, and even entire cities were laid out to mirror constellations. This wasn't coincidence, it was a deliberate, sacred dialogue with the universe. So what happened to this profound connection between architecture and astronomy? Over time, the meaning behind these alignments faded, buried under layers of history and myth. But the stones still whisper their secrets. Today, we're piecing together a puzzle that spans continents and millennia, uncovering how these sky-watching builders shaped human destiny. Their legacy isn't just in the ruins they left behind, it's in the questions they force us to ask. How did they achieve such precision? What cosmic truths were they trying to preserve? And what can their wisdom teach us about our place in the cosmos? This is more than a history lesson. It's a journey into the mind of ancient genius, a chance to stand where they stood and see the sky as they saw it, not just as stars, but as a guide, a clock, and a map to something far greater than ourselves. Think about the sheer patience it must have taken to chart the stars without a single piece of modern technology. The ancients didn't just glance upward. They spent lifetimes tracking subtle shifts in the night sky, recording patterns that repeated over decades, even centuries. Take the Great Pyramid of Giza, for example. Its sides align almost perfectly with the four cardinal directions, a feat so precise that modern engineers still debate how it was achieved. But here's what's truly astonishing. The pyramid's layout mirrors the stars of Orion's belt, as if the builders were recreating the heavens in stone. And they weren't alone. Half a world away, the Mayans built El Castillo at Chichen Itza with steps designed to cast a serpent-like shadow during equinoxes, a dazzling display of light and geometry that still draws crowds today. These weren't just clever tricks, they were expressions of a worldview where earth and sky were inseparable. The Temple of Carnac in Egypt, for instance, was aligned so precisely that on the winter solstice, sunlight would pierce its inner sanctuary, illuminating statues of the gods as if bringing them to life. In Cambodia, Angkor Wat's towers mirror the Draco constellation, while Stonehenge's towering stones frame the sunrise on the summer solstice with eerie accuracy. The more we study these sites, the clearer it becomes. This wasn't random. It was a language, a way of encoding celestial knowledge into the very bones of civilization. What's even more fascinating is how these ideas span the globe, appearing in cultures that supposedly never met. The Incas, the Mesopotamians, the ancient Chinese, all shared this reverence for cosmic alignment. How did they develop such similar practices across vast distances? Some argue it was pure coincidence, but the mathematical precision suggests otherwise. These builders understood cycles, the wobble of Earth's axis, the slow dance of planets, and they built monuments to last, knowing future generations would need these celestial roadmaps. Today, as we uncover more of their secrets, we're left wondering, were they simply honoring the gods, or were they preserving something far more profound, a universal truth about humanity's place in the cosmos? Standing silent on the Salisbury Plain, Stonehenge has baffled scholars for centuries, not just for how it was built, but why. This ring of towering stones isn't merely a monument, it's a meticulously crafted celestial instrument. On the summer solstice, the sun rises directly over the heel stone, casting its first light into the heart of the circle. During the winter solstice, the setting sun aligns perfectly between the tallest trilithons, as if the builders had choreographed a dance between stone and sky. These aren't rough approximations. The alignments are precise enough to function as a Neolithic calendar, tracking the sun's yearly journey with astonishing accuracy. But here's what's even more remarkable. Stonehenge's builders didn't stop at solar events. Recent studies suggest the monument's smaller, blue stones may have been arranged to predict lunar eclipses. Imagine the dedication it took to haul these massive stones over hundreds of miles, then position them just so, all to capture the rhythms of the cosmos. This wasn't just practical astronomy, it was sacred geometry. The arrangement of the stones mirrors patterns found in other ancient sites, like the concentric circles of New Grange in Ireland or the solar alignments of Mnajdra in Malta. It's as if these cultures shared a hidden textbook, one written not in words but in alignments and shadows. What drove these Neolithic builders to invest such effort? Some argue Stonehenge was a temple, a place where the spiritual and celestial worlds met. Others see it as a communal observatory where knowledge of the seasons ensured survival. But perhaps the most compelling clue lies in the bones and artifacts found nearby. Animal remains, pottery, and even human cremations suggest this was a place of pilgrimage, where people gathered to witness the sun's rebirth at solstices, a moment when time itself seemed to pause. The stones didn't just mark the sky, they anchored rituals that connected the living, the dead, and the cosmos. Today, as modern astronomers use supercomputers to map the heavens, Stonehenge stands as a humbling reminder. Its builders lacked written language, metal tools, or even the wheel, yet they decoded the universe with nothing but patience, observation, and stone. The monument's true genius isn't just in its alignments, it's in the way it embodies humanity's oldest quest to find meaning in the stars. Every solstice, when crowds gather to watch the sunrise, we're not just celebrating an ancient feat of engineering. We're keeping alive a conversation that began 5,000 years ago, one stone at a time. The Great Pyramid of Giza doesn't just dominate the desert horizon, it defies time itself. Its four sides align with the cardinal directions with an error margin of just a fraction of a degree, a level of precision that would challenge modern engineers with laser-guided tools. But the real mystery lies in how the ancient Egyptians pulled this off over 4,500 years ago without compasses or satellites. Some researchers believe they used the stars, tracking the circular motion of circumpolar constellations to pinpoint true north. Others suggest they harnessed the sun's shadow during equinoxes, marking the perfect east-west axis. Whatever their method, the result is undeniable. This wasn't just a tomb. It was a celestial compass carved in stone. Look closer, and the pyramid reveals even deeper secrets. Its narrow air shafts, once dismissed as mere ventilation channels, actually point directly to key stars in the night sky. The southern shaft targets Sirius, the brightest star in Earth's heavens, linked to the goddess Isis and the Nile's life-giving floods. The northern shafts align with Orion's belt, a constellation tied to Osiris, the god of rebirth. These weren't random choices, they were cosmic signposts guiding the pharaoh's soul through the afterlife. The ancient Egyptians saw death not as an end but as a journey, and the pyramid was their star map. Then there's the mathematics. The pyramid's base perimeter divided by twice its height gives a number eerily close to pi, the fundamental constant of circles. Its dimensions also mirror the Earth's curvature, with the height representing the planet's polar radius scaled down by 43,200. Coincidence unlikely. These weren't just builders stacking blocks, they were architects weaving astronomy, geography, and sacred geometry into a single, monumental message. What were they trying to tell us? Some argue the pyramid was a repository of lost knowledge, its proportions encoding advanced understanding of the planet and stars. Others see it as a bridge between worlds where earthly power met celestial order. One thing's certain, the Great Pyramid wasn't built in isolation. From Mexico's Pyramid of the Sun to China's Xi'an pyramids, similar structures echo this obsession with cosmic alignment. Were these cultures tapping into a universal truth, or was there something even more profound at work? The stones won't speak, but their alignments shout across millennia, inviting us to look up, measure, and wonder. The Mayans didn't just watch the stars, they built their civilization around them. At the heart of their cities stood towering pyramids, not just as symbols of power, but as precise astronomical instruments. Take El Castillo at Chichen Itza, where every equinox transforms the staircase into a slithering serpent of light and shadow. This wasn't just artistry, it was a meticulously engineered display timed to perfection. The descending shadow of Kukulkan, the feathered serpent god, wasn't merely a spectacle, it was a celestial announcement, marking the moment when heaven and earth connected. But the Mayans' obsession with the cosmos went far beyond symbolism. Their Dresden Codex, one of the few surviving pre-Columbian manuscripts, reveals just how advanced their astronomy truly was. Inside its bark paper pages are detailed charts predicting Venus's movements with an error margin of just 2 hours over 500 years. They tracked lunar cycles, solar eclipses, and even the irregular orbits of planets, all without telescopes or modern mathematics. These weren't just priests jotting down observations. They were scientists calculating cosmic patterns centuries in advance. What's even more striking is how these celestial rhythms shaped their cities. Mayan urban planning wasn't random. Temples, plazas, and ball courts were aligned to mirror the paths of Venus or the solstice sun. At Uxmal, the governor's palace points directly to Venus's southernmost rising position, while Tikal's temples frame the Milky Way like a stone gateway to the heavens. This wasn't just architecture, it was a three-dimensional map of the sky, designed so that every building, every corridor told a story about the universe. Why go to such lengths? For the Mayans, time wasn't linear, it was cyclical, a sacred wheel turning through ages. Their long count calendar, which famously sparked doomsday myths, wasn't about predicting the end of the world. It was a tool for understanding cosmic order, a way to sync human life with the pulse of the cosmos. Eclipses weren't just celestial events, they were moments when the gods spoke. A solstice wasn't just a seasonal shift, it was a renewal of the world's balance. Today, as we piece together their legacy, we're left with a humbling realization. The Mayans didn't separate science from spirituality. To them, the stars weren't distant lights but living forces, woven into the fabric of daily life. Their temples weren't just monuments, they were clocks, calendars, and portals all at once. And perhaps that's their greatest lesson. In a world that often reduces the universe to cold equations, the Mayans remind us that the sky was never just there to be studied. It was meant to be felt, revered, and built into the very stones beneath our feet. Angkor Wat doesn't just rise from the Cambodian jungle, it emerges from time itself. This sprawling temple complex, larger than modern-day Vatican City, was built in the 12th century, yet its celestial alignments point to something far older. The 5 central towers, often mistaken for mere decorative spires, form a near-perfect match to the stars of the Draco constellation, as they would have appeared in 10,500 BCE. That's not a random date. In Hindu cosmology, this era marks the dawn of the Krita Yuga, a golden age of divine harmony. The builders didn't just replicate the sky, they anchored their sacred history in stone. Walk through Angkor Wat's corridors and you're tracing a celestial blueprint. The temple's western entrance aligns with the setting sun during the spring equinox, casting light down the central axis like a golden thread. The outer galleries mirror the movements of the moon, while the surrounding moat reflects the cosmic ocean of Hindu mythology. Every detail feels intentional, as if the architects were translating the heavens into architecture. Even the bas-reliefs tell a story not just of kings and battles, but of celestial deities and cosmic cycles. Why would a 12th century temple encode a sky from 12,000 years earlier? Some scholars argue it's a form of sacred timekeeping, linking the Khmer Empire to a mythical past. Others suggest the alignment preserves ancient astronomical knowledge passed down through generations. There's a third, more tantalizing possibility, that Angkor Wat's builders recognized something universal in the stars, a pattern so profound it transcended epochs. Draco, the dragon constellation, appears across cultures, from Babylonian myths to Chinese astrology, as a symbol of primordial power. By mirroring it, the temple may have been tapping into a shared celestial language. The precision is staggering. The temple's layout accounts for the slow wobble of Earth's axis, a phenomenon called precession that shifts constellations over millennia. To align with Draco as it appeared millennia before their time, the Khmer architects didn't just observe the sky, they calculated its motion across ages. This wasn't guesswork, it was celestial engineering, a fusion of myth and mathematics. Standing in Angkor Wat's central courtyard, you're not just surrounded by stone. You're standing at the intersection of earth and sky, where every pillar and pathway whispers of a forgotten dialogue with the cosmos. The temple challenges our assumptions about ancient knowledge. How did a civilization without telescopes grasp such complex astronomy? What compelled them to build a monument that wouldn't reveal its full meaning for centuries? Angkor Wat isn't just a relic of the past, it's a bridge, one that stretches across time, inviting us to look up and wonder what else the stars might still be waiting to tell us. Stretching across Peru's arid plains, the Nazca lines remain one of the most enigmatic legacies of the ancient world. These colossal geoglyphs, some stretching over 1,200 feet long, aren't just random scratches in the earth. They're a meticulously crafted celestial language, etched into the desert like a giant sketchbook. From towering hummingbirds to spiraling monkeys, the figures are so vast they're only fully visible from the sky, raising an obvious question. How did a culture without flight create art meant to be seen from above? And more importantly, why? The answer might lie in the stars. Certain Nazca lines align precisely with the winter solstice sunset, while others point to the rising positions of key stars like those in the Pleiades cluster. The famous spider glyph, for instance, mirrors the constellation Orion, but with one striking difference: its elongated leg corresponds to a star in Orion's belt that was brighter 2,000 years ago due to stellar evolution. This isn't just art imitating nature, it's a snapshot of the ancient sky frozen in time. Some researchers believe these lines functioned as an astronomical calendar, helping the Nazca people track planting seasons or predict rainfall in one of the driest places on Earth. Others argue they were sacred pathways meant to guide spirits or deities across the celestial realm. Then there's the mystery of their construction. Without aerial surveys or modern tools, the Nazca achieved near-perfect symmetry and proportion by using simple stakes and ropes. They removed the dark topsoil to reveal the lighter earth beneath, creating contrasts that have endured for centuries. But precision wasn't their only challenge. They also accounted for the desert's optical distortions, designing figures that appear undistorted when viewed from specific vantage points on nearby hills. This level of sophistication suggests the Nazca didn't just see these lines as decorations. They were tools, perhaps even portals, bridging the human and divine. What's most haunting is how the Nazca lines blur the line between science and spirituality. The straight-line geoglyphs, some running for miles without deviation, might have been used for ceremonial processions, with participants walking them like celestial tightropes to commune with the gods. The animal figures, meanwhile, could represent constellations or totems tied to fertility myths. In a world where the sky was both clock and scripture, these desert etchings were more than just landmarks. They were a dialogue with the cosmos, written in earth and shadow. Modern technology has only deepened the intrigue. Satellite imagery reveals previously hidden lines forming intricate networks, suggesting the known glyphs might be fragments of a much larger system. Some researchers even propose the lines trace underground waterways, turning the desert into a sacred map of both sky and earth. Whether observatory, temple, or message to the gods, the Nazca lines defy simple explanation. They remind us that ancient civilizations didn't just live under the stars, they wove them into the very ground they walked on, leaving puzzles that still tug at our curiosity today. Every new discovery peels back another layer, revealing not just how the Nazca saw the heavens, but how the heavens might have shaped them. Ancient India's Jantamanta observatories stand as towering monuments to a forgotten age of cosmic mastery. Built in the early 18th century by Maharaja Jai Singh II, these sprawling stone instruments weren't just tools. They were architectural embodiments of a celestial vision stretching back thousands of years. Take the Samrat Yantra, a sundial so precise it can measure time down to a mere 2 seconds. Its shadow moves at 1 millimeter per second, a feat of engineering that rivals modern instruments. But what's truly remarkable isn't just the precision, it's the lineage. These structures echo knowledge preserved in the Vedas, ancient texts that describe planetary motions and constellations with startling accuracy centuries before telescopes existed. The Jantamanta's genius lies in its simplicity. Unlike fragile brass instruments of the era, these were built to last monolithic structures of marble and stone, resistant to war, weather, and time. The Jai Prakash Yantra, for instance, is a hemispherical bowl carved with celestial coordinates, allowing observers to track the sun's path like a giant inverted sky map. The Ram Yantra's towering cylinders measure altitudes of stars with geometric precision, while the Misra Yantra's 5 instruments combine to determine the shortest and longest days of the year. Every curve, every angle was calculated not with computers, but with a profound understanding of trigonometry and the heavens. This wasn't just science for science's sake. In Vedic tradition, astronomy and astrology were inseparable. Eclipses weren't mere celestial events, they were omens, moments when the cosmic balance shifted. Temples were aligned to solstice sunrises, coronations timed to planetary conjunctions, and agricultural cycles dictated by the nakshatras, the lunar mansions of Hindu astrology. The Jantamanta's instruments could predict eclipses years in advance, a skill that granted rulers divine authority. Knowledge of the stars wasn't just academic, it was political, spiritual, and deeply woven into the fabric of daily life. What's often overlooked is how these observatories bridge ancient and modern. The Vedas, composed over 3,000 years ago, describe the precession of equinoxes, a slow wobble in Earth's axis that takes 26,000 years to complete. How did Vedic seers detect this subtle shift without precise instruments? Some argue it was accumulated observation, passed down through generations of sky-watching priests. Others point to the Jyotisha, a branch of Vedic science that treated the cosmos as a living, interconnected system. The Jantamanta didn't emerge from a vacuum. It was the culmination of a tradition that saw the universe as both measurable and sacred. Today, as modern astronomers peer into deep space with billion-dollar telescopes, the Jantamanta offers a humbling counterpoint. Its massive stone instruments remind us that curiosity about the cosmos is timeless. The same questions that drove ancient Vedic scholars: how do the planets move? When will the next eclipse come? What is our place in the universe? Still guide science today. Perhaps that's their greatest legacy, not just the ability to track stars with stone, but the enduring human urge to reach beyond the earthly, to decode the sky, and to find meaning in its infinite patterns. Long before telescopes or star charts, the Babylonians were mapping the heavens with nothing but clay tablets and an unshakable curiosity. Their star catalogues, etched in cuneiform over 3,000 years ago, aren't just relics, they're the bedrock of modern astronomy. Picture a scribe crouched under the Mesopotamian night, carefully noting the position of Venus or the slow drift of Jupiter, unaware they were compiling humanity's first cosmic database. These weren't casual notes. The Babylonians tracked planetary movements with such precision that their eclipse predictions were accurate to within a few hours centuries before the Greeks formalized the zodiac. What set them apart was their relentless pursuit of patterns. They didn't just observe the stars, they quantified them. Take the famous Venus tablet of Amasajuka, a 7th century BC document recording the planet's risings and settings over 21 years. It's more than a log, it's a mathematical masterpiece, revealing the Babylonians' grasp of cyclical celestial events. They even identified the Saros cycle, a repeating 18-year pattern of eclipses still used by astronomers today. This wasn't guesswork, it was systematic science born from nightly vigils and generations of accumulated knowledge. Their influence stretched far beyond Mesopotamia. When Greek astronomers like Hipparchus and Ptolemy later mapped the stars, they built on Babylonian data. The constellations we recognize today, Leo's fierce outline, Scorpio's curved tail, were first catalogued by these ancient sky watchers. But their legacy wasn't just in naming stars. They pioneered the concept of dividing the sky into 12 equal sections, laying the groundwork for the zodiac. Even their sexagesimal number system, based on 60, still echoes in how we measure time: 60 seconds in a minute, and angles 60 degrees in a triangle. Why such dedication to the cosmos? For the Babylonians, astronomy was inseparable from divinity. Planets weren't just wandering lights, they were gods walking the heavens. Eclipses signaled divine displeasure, while planetary alignments foretold kings' fates. Priests scanned the skies not just for knowledge but for survival, interpreting omens to guide empires. Yet beneath the mysticism lay a razor-sharp intellect. Their goal-year texts could predict planetary positions years in advance using intricate arithmetic, a technique so advanced it wouldn't be matched until the Renaissance. The real marvel isn't just what they knew, it's how they preserved it. These clay tablets survived wars, fires, and millennia buried in desert sands, waiting to whisper their secrets to modern scholars. Today, as we peer into deep space with billion-dollar telescopes, we're still following the trail they blazed, recording, calculating, seeking order in the celestial dance. The Babylonians remind us that astronomy didn't begin with high-tech instruments. It began with human eyes, unwavering patience, and the audacity to believe the stars could be understood. Their legacy isn't just in the past, it's in every star chart, every eclipse prediction, every time we look up and wonder what else the night sky might still be waiting to reveal. To the ancient Greeks, the night sky wasn't just a canvas of light, it was an epic poem written in constellations. Every star told a story, every cluster a myth waiting to be remembered. Take Orion, the mighty hunter, forever chasing the Pleiades across the heavens, his belt of 3 bright stars a celestial landmark. According to legend, Orion's boast that he could slay every beast on earth angered the gods, who sent a scorpion to kill him. A tale still echoed in the sky, where Scorpius rises as Orion sets, forever locked in an endless cosmic chase. These weren't just whimsical stories, they were a way of encoding wisdom, morality, and even navigation into the stars, but the Greeks didn't stop at storytelling. They built their world to mirror the heavens. The Parthenon, Athens' crowning jewel, isn't just aligned to the cardinal directions. Its eastern facade frames the rising of the Pleiades during the festival of Panathenaea, a celestial nod to the goddess Athena. Nearby, the Temple of Apollo at Delphi once housed a golden disk representing the constellation Lyra, symbolizing harmony between earth and sky. Even the labyrinthine ruins of Knossos in Crete bear solstice alignments, suggesting that Minoan architects too saw buildings as bridges to the divine. What's striking is how seamlessly the Greeks fused science and myth. Centuries before Ptolemy penned his star catalogues, Homer's Odyssey described the stars as guides for sailors, a practical truth wrapped in poetry. The constellation Ursa Major, the Great Bear, wasn't just a navigational tool, it was Callisto, a nymph transformed by Zeus to protect her from Hera's wrath. The planet Venus wasn't merely a bright light, it was Phosphorus, the morning star, and Hesperus, the evening star, 2 sides of the same celestial deity. This duality reveals a profound truth. To the Greeks, astronomy and theology weren't separate disciplines. They were 2 languages describing the same cosmic mystery. Why did this matter? Because the stars were more than distant lights, they were active players in human destiny. The Greeks believed celestial events foretold earthly outcomes. A comet might herald a king's death, as it did for Julius Caesar. An eclipse could signal divine displeasure, like the one that darkened the sky before the Battle of Hollies, sending warring armies into retreat. Even the zodiac, inherited from the Babylonians, was reimagined as a celestial theater, with each sign tied to myths of heroes, monsters, and gods. Today, as we separate science from folklore, we risk losing the awe that once accompanied stargazing. The Greeks remind us that the universe isn't just equations and orbits, it's a living narrative, where human struggles and triumphs are written in the stars. Their legacy isn't just in the myths they left behind, but in the way they dared to see the cosmos not as a cold void, but as a mirror, reflecting our deepest questions about who we are and why we're here. When we look up at Orion's belt or the shimmering Pleiades, we're not just observing. We're stepping into a story thousands of years in the making, one where the sky isn't just above us but within us. High on the slopes of Mount Parnassus, the Oracle of Delphi wasn't just a woman, she was a conduit between earth and sky. When kings and generals journeyed to her sanctuary, they weren't just seeking advice, they were pleading for clarity from the cosmos itself. The temple's very design whispers of this celestial connection. Its entrance faced east, aligning with the rising sun during key festivals. while the Aditon, the sacred chamber where the Pythia delivered her prophecies, was said to emit vapors that connected her to divine forces. But recent studies suggest these vapors might have been more than myth. Geological surveys reveal intersecting fault lines beneath the temple, possibly releasing ethylene or methane gases that induced trance-like states. Combine this with flickering torchlight reflecting off gold-covered walls, and you have a space designed to mimic the shimmering heavens, blurring the line between priestess and constellation. The stars didn't just backdrop the oracle's rituals, they shaped them. Historical accounts describe how celestial events like the Great Comet of 373 BCE, which blazed over Greece for months, were interpreted as omens of war or plague. An eclipse in 413 BC allegedly halted the Athenian retreat from Syracuse, convincing generals the gods demanded they stay, a decision that led to catastrophic defeat. These weren't mere superstitions. The priests of Delphi maintained detailed records of astronomical cycles, recognizing patterns we now attribute to orbital mechanics. A comet might signal upheaval, but its recurrence every 76 years, like Halley's, suggested order beneath the chaos. The Pythia's famed ambiguity, her riddling prophecies, may have been a deliberate mirror of the sky's own cryptic language. What's often overlooked is how the temple's architecture encoded celestial knowledge. The tholos, Delphi's circular sanctuary, mirrored the cosmos in miniature, its 20 Doric columns representing the lunar cycle, while the three-step platform echoed the three realms of earth, sky, and underworld. Even the omphalos, the sacred navel stone marking Delphi as the center of the world, was adorned with a mesh pattern mimicking the celestial grid. Pilgrims didn't just come for predictions, they came to align themselves with cosmic harmony, to stand where heaven and earth intersected. The oracle's true power lay in synthesis. She didn't just read stars, she wove them into the fabric of human choice. When King Croesus of Lydia asked whether to attack Persia, her response, "If you cross the river, a great empire will fall," wasn't just clever wordplay. It reflected a worldview where celestial timing dictated action. The right moment to wage war wasn't just tactical, it was written in planetary alignments. Modern scholars debate whether the Pythia's visions were chemically induced, psychologically crafted, or divinely inspired, but perhaps the answer lies in the intersection of all three. The stars provided the framework, the gases opened the mind, and the priestess translated the message. Delphi's legacy challenges our modern divide between science and spirituality. Today, we dismiss omens as coincidence, yet we still check horoscopes or marvel at eclipses. The ancients understood something we often forget. The sky doesn't just inspire awe, it invites interpretation. Every comet, every alignment, every shadow crossing the sun was a stroke in a grand celestial narrative, and the oracle was its most eloquent reader. In a world where GPS guides our steps and algorithms predict our choices, Delphi reminds us that once, humanity looked up not just to navigate, but to understand. The stars were more than lights, they were a language, and for 1,000 years, the oracle was its most fluent speaker. In the celestial imagination of ancient China, the night sky wasn't just a scattering of stars, it was a vast imperial court suspended in eternity. The North Star, known as the Purple Forbidden Enclosure, sat like an emperor on his throne, surrounded by constellations representing ministers, armies, and even prisons. This wasn't mere poetry. It was a meticulously documented system where every flicker in the heavens carried weight on Earth. When a comet streaked across the sky in 1054, Chinese astronomers recorded it not just as an astronomical event, but as a portent of upheaval, a celestial memo demanding the emperor's attention. The Forbidden City in Beijing embodies this cosmic blueprint down to its very foundations. Its layout mirrors the purple forbidden enclosure, with the emperor's throne room positioned as the earthly counterpart to the North Star. Gates aligned with solstice sunrises, while halls faced cardinal directions, turning the palace into a terrestrial map of the heavens. Even the number of roof figurines, 9 mythical creatures on the Hall of Supreme Harmony, reflected the celestial hierarchy, as 9 was the emperor's sacred number. This wasn't just symbolism, it was political theology in stone, declaring that the ruler's authority came not from men, but from the cosmos itself. What's astonishing is how deeply astronomy influenced statecraft. The Chinese court employed full-time astrologers to maintain the Tianwenji, celestial records that spanned centuries. These weren't dry scientific logs, they were urgent bulletins linking cosmic events to earthly affairs. A supernova in 1054, now identified as the Crab Nebula's birth, was interpreted as a challenge to the emperor's mandate. Planetary conjunctions could delay military campaigns or trigger tax reforms. The sky wasn't just observed, it was consulted like a divine advisor. Yet beneath the mysticism lay breathtaking precision. The Dunhuang star chart, dating to the Tang dynasty, is the oldest complete star map in existence, plotting over 1,300 stars with remarkable accuracy. Chinese astronomers tracked the slow drift of the celestial pole centuries before Western science acknowledged Earth's axial precession. Their records of guest stars, as sudden bright points we now know as supernova, remain invaluable to modern astrophysicists studying stellar life cycles. Perhaps most fascinating is how this system endured. While medieval Europe saw comets as harbingers of doom, Chinese astronomers like Guo Shaojing calculated their orbits using spherical trigonometry. The Ming dynasty's observatory in Beijing featured bronze instruments calibrated to track planetary motions with uncanny foresight. This blend of empirical rigor and cosmic philosophy raises a provocative question. Did China's celestial bureaucracy actually advance their astronomy by treating the sky as a living, administrative entity? When stars aren't just objects but actors in a grand cosmic drama, perhaps it sharpens the urgency to understand their movements. Today, as satellites orbit where ancient astrologers once gazed, China's star lore offers more than historical curiosity. It's a reminder that every culture maps the heavens through its own lens, not just with telescopes, but with myths, politics, and the unshakable human instinct to find order in the infinite. The Forbidden City still stands, its alignment unchanged, a silent testament to an age when rulers looked up not just to navigate, but to legitimize, prophesize, and commune with the very machinery of the universe. The vast Pacific Ocean stretches for thousands of miles with no landmarks in sight, yet the Polynesian wayfinders crossed it as effortlessly as we might follow a highway. Without compasses, sextants, or even written records, they navigated the open sea by reading the stars like a celestial roadmap. Imagine standing on the deck of a double-hulled canoe, feeling the swell of the waves beneath you while your eyes trace the path of Hokulea, the star we call Arcturus, as it rises precisely over your home island. That's not just navigation, it's a conversation with the cosmos. The Hawaiian star compass, or Hokupa, wasn't just a tool, it was a living mental map. The horizon was divided into 32 directional houses, each anchored by a specific star or constellation. When Hokulea rose in the northeast, it signaled the way to Tahiti. When Sirius blazed directly overhead, it marked latitude like a natural GPS. But stars alone weren't enough. Wayfinders memorized the rhythmic patterns of swells, sensing disruptions that hinted at distant islands. They watched for birds like the Monu Oku, whose flight paths at dusk pointed toward land. Even the color of the clouds carried meaning. A greenish tint might reflect lagoons miles beyond the horizon. This knowledge wasn't stored in books but in chants, stories, and years of apprenticeship. Master navigators like Mau Piailug, who revived these nearly lost techniques in the 1970s, could recite star paths for hundreds of miles from memory. They didn't just memorize positions, they internalized the sky's movements, feeling the tilt of the canoe beneath them adjust to the stars' shifting angles. The Polynesians didn't conquer the Pacific, they befriended it, learning its rhythms so deeply that the ocean itself became a guide. Modern science is only now catching up to their brilliance. Researchers have discovered that Polynesian star paths account for something called stellar precession, the slow wobble of Earth's axis that gradually shifts star positions over centuries. Their oral traditions preserved corrections for these shifts, a feat requiring generational observation. NASA even studied their wave pattern navigation to improve autonomous drone systems. Yet perhaps their greatest lesson isn't technical but philosophical. In an age of satellite dependence, the Wayfinders remind us that true navigation isn't just about reaching a destination, it's about understanding your place in a vast, interconnected world. The revival of Polynesian voyaging in recent decades proves this wisdom hasn't faded. When the Hokulea canoe sailed around the globe using only traditional navigation in 2017, it wasn't just a cultural statement, it was a beacon. The stars that guided their ancestors still shine, waiting for anyone willing to look up and learn their language. In a way, we're all wayfinders charting our course through life's uncertainties. The Polynesians just had the courage to do it under an open sky with nothing but the stars as their compass. In the arid plains of Mali, the Dogon people guard a secret that defies conventional history. For generations, their oral traditions have spoken of Sirius B, a dense, invisible companion star orbiting Sirius, the brightest star in our night sky. What's astonishing isn't just their awareness of this dwarf star, but the precision of their knowledge. They describe its 50-year elliptical orbit, its intense density, and even its white color details impossible to discern without advanced telescopes. Yet the Dogon knew, long before Western astronomers confirmed Sirius B's existence in 1862, their creation myths wove this celestial dance into the fabric of their culture. How could a remote tribe possess such sophisticated astronomy? Some point to their intricate cosmology, where Sirius B, called Potolo, is central to their origin stories. According to Dogon elders, amphibious beings from the Sirius system, the Nommo, brought this knowledge to Earth millennia ago. These ancestral teachers allegedly descended in a fiery vessel, imparting wisdom about the stars before vanishing into legend. Skeptics dismiss this as myth, suggesting the Dogon might have absorbed the information from European visitors in the 1900s. But here's the catch. French anthropologists recorded the Sirius lore in the 1930s, years before mainstream science had fully mapped Sirius B's orbit. The plot thickens when you examine the Dogon's celestial rituals. Every 50 years, they celebrate the Sigwi festival, a ceremony that mirrors Sirius B's orbital period. Masked dancers reenact the Nommo's arrival, while elders recount star maps that align with modern astrophysics. Even their granary doors are carved with Sirius's 3-star system, a detail only visible with infrared imaging. Could this be coincidence or evidence of lost knowledge passed down through centuries? Mainstream scholars offer alternative explanations. Some propose that the Dogon's observations of Sirius's slight wobble caused by its invisible companion's gravity might have hinted at Sirius B's presence. Others argue that cultural contamination, like contact with astronomers during colonial times, could have influenced their lore. but these theories struggle to explain the depth and specificity of the Dogon's astronomical claims, embedded so deeply in their language and rituals. Perhaps the most compelling question isn't how the Dogon knew, but why this knowledge mattered so profoundly to them. In their worldview, Sirius wasn't just a star, it was the axis of spiritual and earthly order. Their architecture mirrors its celestial movements, their agricultural cycles sync with its position. This wasn't science for curiosity's sake, it was a sacred covenant, a way of harmonizing human life with cosmic rhythms. The Dogon mystery forces us to reconsider the boundaries of ancient wisdom, whether their knowledge came from celestial observation, ancestral memory, or something more enigmatic. It challenges the assumption that advanced astronomy is purely a modern achievement. Their story lingers like a star's afterglow, visible only if you're willing to look beyond the light of conventional understanding. Deep beneath the rolling green hills of Ireland, New Grange waits, a 5,000-year-old passage tomb that transforms into a celestial clock once a year. For 17 minutes at dawn on the winter solstice, a narrow beam of sunlight pierces the tomb's roof box, crawling inch by inch until it illuminates the inner chamber in a golden blaze. This isn't just a happy accident of architecture. The entire structure was engineered with staggering precision, the corridor angled exactly to capture that fleeting moment when the sun seems to stand still in the sky. Modern attempts to replicate this alignment have proven how difficult it is. Even a single degree of error would throw the entire phenomenon off. Yet somehow, Neolithic builders achieved this without metal tools, written language, or even the wheel. Across the Irish Sea, the Carnac stones stretch over France's Brittany coast like a petrified army. 11 rows of nearly 3,000 megaliths, some standing 20 feet tall. At first glance, they seem randomly placed, but aerial views reveal a startling pattern. The stones align with both the sunrise and moonrise during major lunar standstills, events that occur only every 18.6 years when the moon reaches its farthest points in the sky. The largest stones mark the most extreme positions, creating a colossal calendar carved in granite. What's mesmerizing isn't just the scale. It's the implication that generations of builders worked across centuries to track a cycle longer than a human lifetime. These sites raise a haunting question. Why would scattered cultures with no apparent contact share such intricate sky knowledge? In Spain's Andalusia region, the Dolmen of Menga, a massive stone tomb, frames the summer solstice sunrise, while Sweden's Ale stones form a ship-like monument pointing to the winter solstice. From the Callanish stones in Scotland to Malta's Haga Kim, the same patterns repeat. It's as if prehistoric Europe whispered a secret across thousands of miles, a belief that the dead, the earth, and the heavens were bound together. Archaeologists still debate whether these sites were tombs, temples, or observatories. The bones found at New Grange suggest burial rites, but the solstice alignment hints at something more. Perhaps these weren't just places to honor the dead, but portals where the living could commune with cosmic forces. The winter solstice, after all, marks the sun's rebirth, a turning point when light begins its slow return. What better moment to link the departed with the promise of renewal? The true genius of these builders lies in their patience. Unlike modern astronomers who chase instant data, they thought in lifetimes and generations. A mistake in aligning New Grange wouldn't be noticed for years, maybe not until the next solstice. The Carnac stone's lunar alignments required observations spanning decades. This wasn't just astronomy, it was an act of faith, a covenant between earth and sky written in stone. Today, as crowds gather at New Grange's winter dawn or walk the Carnac rows under a rising moon, we're not just witnessing ancient science. We're stepping into a 5,000-year-old conversation, one where the dead, the living, and the cosmos still speak the same silent language. High atop the mesas of the American Southwest, the ancestral Puebloans, often called the Anasazi, carved their story into the very bones of the desert. Their cliff dwellings at places like Mesa Verde and Choco Canyon weren't just shelters. They were celestial observatories engineered with a precision that still leaves scientists in awe. Take the Sun Dagger at Fajoda Butte, where 3 slabs of rock slice sunlight into razor-thin beams that strike spiral petroglyphs, marking the summer solstice with a dagger of light, the equinoxes with a bisecting line, and the winter solstice with twin daggers framing the spiral. This wasn't just art, it was a solar calendar etched in stone, tracking the years turning with unerring accuracy. But the ancestral Puebloans didn't stop at the sun. At Choco Canyon, the massive Pueblo Bonito's walls align with the cardinal directions, while its eastern doorway frames the rising sun during equinoxes. Nearby, the petroglyph known as the supernova pictograph may depict the explosive stellar event of 1054, a celestial cataclysm visible even in daylight for weeks. Most astonishing of all are the markings tracking the moon's subtle 18.6-year cycle, a pattern so complex it requires generations of observation. How did a culture without written records master such advanced astronomy? The answer might lie in their patience. Unlike modern astronomers who measure time in grand cycles, the ancestral Puebloans thought in lifetimes, passing knowledge through oral traditions and stone alignments that functioned as teaching tools. Then, around the 13th century, something changed. The great houses of Choco were abandoned, their doorways sealed, their celestial markers left silent. Drought, resource depletion, or social upheaval might explain the exodus, but what happened to their star knowledge? Some scholars believe it migrated with the people, resurfacing in the Kiva rituals of modern Pueblo tribes, where solstice ceremonies still honor the sun's return. Others point to the Hopi, whose cosmology speaks of a blue star Kachina heralding cosmic change, a possible echo of ancestral observations. The truth may be even more profound. Perhaps the ancestral Puebloans didn't lose their celestial wisdom. They simply encoded it differently, trading stone alignments for stories, petroglyphs for prayers. Today, as archaeologists scan Choco's ruins with LiDAR and astronomers decode its petroglyphs, the canyon whispers of a time when the sky wasn't just watched, it was woven into daily life. The ancestral Puebloans remind us that astronomy isn't just about data, it's about meaning. Their buildings weren't just aligned to the stars, they were conversations with the cosmos, a way of asking, where do we belong? The answer, it seems, is written in sunlight and shadow, waiting for those who know how to read it. Among the towering peaks of ancient Persia, fire wasn't just a symbol, it was a celestial messenger. Zoroastrian priests studied the heavens with a devotion that blurred the lines between science and prayer, their sacred flames mirroring the eternal light of the stars. At the heart of their rituals stood the fire temples, strategically aligned so that the equinox sunrise would ignite the central altar with a precision that still baffles modern scholars. The temple of Adur-Gushnasp, for instance, was positioned to catch the first rays of the spring sun, transforming the dawn into a divine spectacle. This wasn't just architecture, it was a sacred dialogue with the cosmos, where every beam of light carried spiritual weight. The festival of Nowruz, celebrated for over 3,000 years, captures this celestial harmony perfectly. Falling on the spring equinox, it marks not just the new year but the moment when day and night stand in perfect balance, a cosmic reset woven into Persian culture. Ancient astronomers tracked this event using intricate star charts, ensuring the festival began the instant the sun crossed the celestial equator. Even today, families gather around haft-sin tables adorned with 7 symbolic items, each representing a celestial body or earthly element, bridging the gap between heaven and home. The tradition isn't just cultural, it's a living artifact of Persia's star-guided legacy. Scattered across Iran's rugged landscape, structures like the Calais Doctor Fortress hint at a deeper astronomical purpose. Its strategic placement and narrow windows suggest it may have doubled as an observatory, where priests tracked the movements of Sirius or the shifting path of Venus. Some researchers believe these towers functioned as early solstice markers, their shadows stretching like celestial clock hands across the desert floor. The Zoroastrians didn't just observe the stars, they integrated them into every facet of life, from agriculture to law. Crops were sown under auspicious constellations, and legal contracts were signed only when certain planets aligned, ensuring cosmic favor. This celestial wisdom didn't vanish with the fall of Persia. When Islamic scholars like al-Biruni and Omar Khayyam revolutionized astronomy centuries later, they built upon Zoroastrian foundations. The famed Samanid observatories borrowed techniques from ancient star charts, while Persian lunar calculations refined the Islamic calendar. Even the astrolabe, a marvel of medieval navigation, owes its precision to earlier Persian models. The legacy lingers in unexpected places. Modern Tehran's Milad Tower, for example, echoes the ancient fire temples with its equinox alignments, proving that the sky's pull on Persian culture never truly faded. What made these sky watchers unique wasn't just their accuracy, but their vision. They saw the universe as a living, breathing entity where fire and stars shared a common language. In a world that often separates science and spirituality, their legacy challenges us to look up and remember the heavens aren't just there to be measured. They're there to be felt, and perhaps that's why, after millennia, the flames of Nowruz still burn bright, a testament to the enduring power of a culture that dared to weave its destiny among the stars. The vast, unbroken deserts of Arabia might seem like a barren wasteland to outsiders, but to the Bedouin tribes who called it home, the night sky was a living clock. Without landmarks to guide them, they turned to the stars, mapping the heavens into 28 lunar mansions known as the Anwa. Each marked the rising and setting of specific stars, signaling shifts in seasons, the arrival of rains, or the perfect time to move their herds. Picture a caravan navigating the Rub al-Khali, the empty quarter, guided not by maps but by the shimmering arc of Al-Thuraya, the Pleiades, as it heralded the winter monsoon. This wasn't just navigation, it was survival, written in the constellations. The Anwa system was more than practical, it was poetry in motion. Tribes named the lunar mansions after the natural events they heralded. Al-Jabha, the forehead, marked by the star Regulus, signaled the scorching heat of high summer. Al-Batan al-Hut, the belly of the fish, warned of looming sandstorms when Fomalhaut dipped below the horizon. These celestial markers weren't arbitrary. They were woven into oral traditions, recited in verse by generations of poets who transformed star lore into cultural memory. Even today, fragments of these sky-bound rhythms linger in Arabic proverbs and seasonal rituals, a testament to how deeply the cosmos shaped desert life. When Islam emerged in the 7th century, it didn't erase this celestial wisdom, it refined it. Caliphs like Al-Mamun turned Baghdad's house of wisdom into a beacon of astronomy, where scholars like Al-Farghani compiled star tables with unprecedented precision. The astrolabe, a handheld computer of the medieval world, evolved from Bedouin star sticks into intricate brass instruments that could calculate prayer times, track planetary movements, or even determine the Qibla, the direction to Mecca, from anywhere on Earth. The desert star clocks had birthed a scientific revolution. What's often overlooked is how this fusion of tradition and innovation mirrored Arab identity itself. The same tribes who once followed the Anwa now measured the heavens with quadrants and armillary spheres, yet the goal remained unchanged: to harmonize human life with cosmic order. The stars that guided caravans still gleamed in the mosaics of Umayyad mosques, their light now refracted through geometric patterns symbolizing infinity. The desert sky, once a practical tool, had become a bridge between Earth and the divine. Modern astronomers still rely on this legacy. The Arabic names of stars, Altair, Vega, Betelgeuse, echo across observatories today, while algorithms in satellite navigation owe a debt to those first lunar mansion calculations. But perhaps the true lesson lies deeper. In an age of GPS and atomic clocks, the Anwa remind us that science doesn't erase tradition. It builds upon it, layer by layer, just as the desert sands preserve the footprints of those who once walked beneath the stars, reading time in their glow. Across the sweeping savannas and dense rainforests of Africa, the night sky was never just a backdrop, it was a living storybook. To the Sand people of the Kalahari, the Milky Way wasn't merely a band of light, it was the backbone of the night, a shimmering path where spirits traveled between worlds. They read the stars like tracks in the sand, interpreting the flicker of canopus as a signal to begin the seasonal hunt or the rising of the Pleiades as a call to harvest. Their rock art, some dating back thousands of years, depicts celestial beings with arms outstretched like constellations, blurring the line between myth and astronomy. In Mali, the Bambara people wove the cosmos into their very origin stories. They believed Sirius, the brightest star in Earth's sky, was the home of the creator god Amma, who shaped the universe by spinning a cosmic egg. This wasn't just poetic symbolism. The Bambara's ceremonial masks and dance rituals mirrored the stars' movements, with initiates reenacting the celestial dance of creation. Even their agricultural cycles aligned with Sirius's heliacal rising, marking the arrival of rains with a precision that modern meteorologists would admire. Then there's Great Zimbabwe, the sprawling stone city whose ruins still whisper of celestial secrets. The conical tower at its heart aligns with the rising of the Southern Cross during the winter solstice, while the eastern enclosure's walls frame the summer solstice sunrise. Archaeologists have found pottery shards marked with star-like patterns, suggesting the city's rulers didn't just track the heavens, they encoded them into daily life. Some scholars argue the entire layout mirrors the constellation Centaurus, turning the city into a terrestrial echo of the sky. What unites these traditions isn't just a fascination with stars, it's the belief that the cosmos is active, alive, and intimately tied to human existence. The Dogon's reverence for Sirius B, the Yoruba's association of Orion with the warrior god Ogun, the Zulus' Enkanyazi, star lore guiding pastoral journeys, all reflect a shared understanding. The sky wasn't something to observe from a distance. It was a participant in life's rhythms, a teacher, a guide. Modern telescopes may map galaxies light years away, but Africa's star myths remind us of something profound. Long before satellites or spectrometers, these cultures grasped a truth we often forget: that astronomy isn't just about measuring light, it's about meaning. When a San elder points to the Milky Way and speaks of ancestors, or a Bambara storyteller recounts Sirius's role in creation, they're not just preserving myths. They're keeping alive a conversation with the universe that began when humanity first looked up and wondered. For the Pawnee people of the Great Plains, the night sky wasn't just a spectacle, it was the blueprint for their entire world. Their earth lodges, circular dwellings sunk into the ground, were more than homes, they were microcosms of the universe. The ceiling represented the dome of the sky, with its central smoke hole aligning to Polaris, the North Star, around which all other stars seemed to revolve. The 4 posts supporting the roof mirrored the 4 cardinal directions, while the floor's carefully raked patterns echoed the paths of constellations like the Pleiades and Scorpius. This wasn't mere decoration, it was sacred geometry, a way of bringing celestial order down to Earth. The Pawnee took this harmony further with their star charts, intricate hide paintings mapping the heavens to guide rituals and agricultural cycles. Priests known as star keepers memorized these celestial patterns, using them to determine when to plant corn or hold ceremonies. The arrival of the Skiddy band's namesake, the wolf star, now called Sirius, marked the summer solstice, signaling the time for the morning star sacrifice, a ritual ensuring cosmic balance. To modern eyes, this might seem like superstition, but consider the precision. Their star charts accurately depicted the heliacal rising of Venus, an event recurring every 584 days. Without telescopes or written records, they tracked planetary cycles with astonishing accuracy, embedding astronomy into every facet of life. Far to the southwest, the Hopi people watched the same stars but heard a different message. Their prophecies speak of the blue star Kachina, a celestial sign heralding the dawn of a new age. According to tradition, when this blue-hued star appears, it will mark a time of purification and renewal. Some researchers link this prophecy to the return of Halley's Comet, which blazed across the sky in 1910, while others suggest it foretells the appearance of a supernova or even a planetary alignment. But for the Hopi, the blue star isn't just an astronomical event, it's a moral compass, a reminder to live in harmony with nature and prepare for Earth's spiritual transformation. What unites these traditions is their view of the cosmos as a living, breathing entity. The Lakota's Black Elk described the Milky Way as the spirit road, a path souls traveled after death. The Cherokee planted crops according to the Corn Mother constellation, what we call Gemini, while the Navajo used star patterns to time their sacred chantway ceremonies. Unlike Western astronomy, which often separates science from spirituality, these cultures saw no divide. A comet wasn't just ice and dust, it was a messenger. A solstice wasn't merely an orbital milestone. It was a moment when the veil between worlds grew thin. Today, as light pollution erases the stars for millions, these traditions offer more than historical curiosity. They're a challenge to see the sky not as a void to be conquered, but as a mirror reflecting our place in a vast, interconnected web. When a Pawnee elder looked up, they didn't just see points of light, they saw ancestors' stories and instructions for living. The Hopi Blue Star prophecy, whether literal or symbolic, urges us to consider how we might align our own lives with cosmic rhythms. The stars these cultures revered still shine, waiting for us to remember their language, not just of motion and mass, but of meaning. Long before horoscopes were reduced to newspaper snippets, astrology pulsed as the lifeblood of ancient civilizations, a sacred dialogue between humanity and the cosmos. In the shadow of Babylon's ziggurats, priests tracked Jupiter's path not for personal predictions but to divine the fate of empires. A king's coronation might be delayed for months until Venus aligned with the Pleiades, signaling celestial approval. This wasn't entertainment, it was statecraft written in starlight. The Egyptians took it further, carving zodiacs into temple ceilings like denderahs, where the goddess Nut arched across the heavens, swallowing the sun each evening to birth it anew at dawn. Here, astrology and astronomy weren't separate disciplines. They were twin faces of a single truth, that human lives were threads woven into a grand celestial tapestry. The turning point came when the stars shifted from rulers to individuals. Greek thinkers like Ptolemy played a pivotal role, systematizing astrology in his Tetrabiblos while simultaneously advancing astronomy's mathematical rigor. His work preserved Babylonian star lore but reframed it, suggesting planets influenced not just kingdoms but personal temperaments. A child born under Mars might inherit courage. Mercury's alignment could bless eloquence. This democratization of the cosmos was revolutionary, yet it also planted the seed of division. As Hellenistic cities flourished, street astrologers began offering private readings, decoupling celestial wisdom from temple rituals. The stars were no longer just divine messengers, they'd become mirrors for the self. What's often overlooked is how deeply astronomy remained embedded in early astrology. Medieval Islamic scholars like al-Biruni produced stunningly accurate ephemerides tables tracking planetary positions, while simultaneously refining astrological interpretations. Renaissance polymaths from Kepler to Galileo cast horoscopes for patrons even as they mapped the heavens. The rift between the two fields was gradual, fueled less by ideology than technology. Telescopes revealed planets as physical worlds, not wandering gods. Newton's laws explained orbits through gravity, not metaphysical forces. By the 18th century, Europe's Enlightenment thinkers dismissed astrology as superstition, while astronomy marched forward as a hard science. Yet the ancient connection lingers in unexpected ways. Modern astronauts still nickname spacecraft after mythological figures: Apollo, Orion, Artemis, echoing the old bond between cosmic exploration and human meaning. And perhaps that's the real lesson of astrology's origins. Whether as sacred science or personality quiz, it endures because it answers a primal need. The Babylonians gazing at Jupiter, the Egyptians charting Nut's starry belly, even today's casual horoscope reader, all share the same longing, not just to understand the heavens but to feel seen by them. Rising from the cobblestone streets of medieval Europe, Gothic cathedrals like Chartres weren't just monuments to faith. They were stone and glass telescopes turned inward, capturing celestial rhythms in their very bones. Step inside Chartres on the summer solstice, and you'll witness a spectacle that's been unfolding for 800 years. As the sun climbs to its zenith, a single beam of light pierces a tiny aperture high in the south transept, striking a metal plaque embedded in the floor. This isn't accidental artistry. The cathedral's architects engineered the alignment with precision, transforming sunlight into a sacred timekeeper that marks the years turning with liturgical solemnity. The stained glass windows tell an even deeper story. Far more than biblical illustrations, they function as celestial filters. The famous blue Virgin window bathes the north aisle in ethereal cobalt only during the winter solstice, when the low sun angles through its dense pigmentation. Meanwhile, the three lancet windows above the royal portal align with sunset on the feast days of the Virgin Mary, casting ruby and gold light across the nave like divine brushstrokes. These weren't random choices. Medieval craftsmen mixed metallic oxides into their glass to create specific light transmission properties, effectively turning the cathedral into a colossal astronomical instrument that marked holy days through chromatic alchemy. Then there's the labyrinth, the 30-foot-wide circular maze inlaid in the nave's floor. While pilgrims today walk it as a meditative practice, its original purpose may have been celestial. The path's 11 concentric circles mirror the nested orbits of medieval cosmology, while its overall dimensions match the proportions of the rose window above the west facade. Some scholars suggest the labyrinth was a symbolic pilgrimage to Jerusalem, but others see a more esoteric function, a walking meditation on the harmony of spheres, where physical movement mirrored the soul's journey through cosmic order. What's most startling is how these features connect across continents and eras. The same geometric principles that govern Chartres' floor plan appear in Cambodia's Angkor Wat and Egypt's Temple of Carnac, sites equally obsessed with solstice alignments. Were medieval masons privy to lost knowledge passed down through guilds? The cathedral's sculpted, green man foliage mirrors Mayan stone carvings of the world tree, while its sacred geometry adheres to the same ratios found in Babylonian star temples. Even the cathedral's orientation, slightly skewed from true east, aligns with the sunrise on the feast of Saint John the Baptist, suggesting a deliberate fusion of Christian liturgy and prehistoric solar worship. Modern laser scans reveal even subtler genius. The slight bulges in Charter's pillars counteract optical illusions caused by the building's curves, ensuring perfect visual harmony. The flying buttresses aren't just structural, they cast shadows that trace the sun's annual path across the floor like a sundial. Every element whispers of a time when architecture wasn't just functional, it was cosmological. These builders didn't separate faith from physics. To them, measuring the heavens and glorifying God were one and the same. The cathedral wasn't just pointing to heaven, it was a living model of it, inviting worshippers to step inside the universe's grand design and find their place among the stars. The real mystery isn't how they achieved such precision with rudimentary tools. It's why this celestial language faded. As the Renaissance dawned, cathedrals became more about human grandeur than cosmic communion. The stars retreated from the naves, leaving behind a silent testament in stone and glass, a reminder that once, humanity built not just to reach the heavens, but to understand them. The year 1543 marked a cosmic turning point, not in the heavens but in the human mind. When Copernicus's On the Revolutions hit print just before his death, its radical claim that Earth orbited the Sun, not the other way around, ignited a firestorm. Yet few realize how deeply this revolution was rooted in antiquity. Copernicus himself credited the ancient Greek astronomer Aristarchus of Samos, who proposed a heliocentric model 17 centuries earlier but was dismissed as heretical. The Renaissance wasn't just inventing new ideas, it was exhuming old ones, dusting off star charts from Alexandria's burned library and Babylonian clay tablets to rewrite humanity's place in the cosmos. Galileo's telescope may have revealed Jupiter's moons in 1610, but his real breakthrough came from comparing his observations with Ptolemy's 2nd century Almagest. The Greek-Egyptian scholars' star catalogue, preserved by Islamic scholars during Europe's Dark Ages, gave Galileo the baseline to prove planets didn't move in perfect circles as medieval dogma insisted. Without those ancient reference points, his discovery of Venus's phases, the smoking gun for heliocentrism, might have been dismissed as optical illusions. The irony, Ptolemy himself had clung to Earth-centered cosmology, yet his meticulous data became the rope that hanged it. This revival wasn't limited to Europe. Tycho Brahe's groundbreaking star maps, which laid the groundwork for Kepler's laws of planetary motion, borrowed observational techniques from the Persian astronomer Nasir al-Din al-Tusi's 13th century Maragha Observatory. Even the telescope's design traces back to Arabic treatises on lens grinding. The Renaissance's scientific explosion wasn't a sudden spark. It was an ember nursed for centuries in Baghdad's House of Wisdom, Byzantine monasteries, and the oral traditions of star-watching cultures worldwide. What's often overlooked is how these astronomers navigated between reverence and rebellion. Kepler blended Pythagorean musical theory with Martian orbital data, convinced the planets sang harmonic music of the spheres. Galileo framed his discoveries as rediscoveries, telling the Medici family Jupiter's moons honored their dynasty, just as the ancients had named planets for gods. This strategic nostalgia made radical ideas palatable, a lesson modern science communicators might heed. The deeper mystery lies in the data gaps. How did Copernicus calculate Earth's orbital tilt within 1 degree of accuracy without telescopes? Some scholars suspect he accessed lost Hellenistic texts or Egyptian water clocks that tracked precession. Galileo's notes reference Chaldean methods for predicting eclipses, techniques from Babylonian astrologers whose precision still stumps historians. These weren't just lucky guesses, they were fragments of a vast intergenerational project where each civilization built on what came before, even when the original builders were forgotten. The Renaissance teaches us that scientific progress isn't a straight line. It's a spiral, looping back to ancient truths with fresh eyes. When we celebrate Galileo turning his telescope skyward, we're also honoring the Arab lens grinders, the Greek geometers, and the unnamed stargazers who first wondered why Venus flickered. Their legacy isn't just in what we know, but in how we remember that every giant leap stands on shoulders reaching back to the dawn of curiosity. Modern tools are peeling back layers of time, revealing just how meticulously ancient builders wove astronomy into their monuments. At Turkey's Göbekli Tepe, a site dating back nearly 12,000 years, archaeologists armed with 3D laser scanners made a startling discovery. The circular enclosures, adorned with intricate animal carvings, aren't just randomly oriented. Their pillars align with the rising of Sirius and other key stars as they would have appeared in 10,000 BC. This predates Stonehenge by 6 millennia and rewrites the history of human celestial observation. LiDAR technology, which strips away vegetation to expose hidden structures, has uncovered similar precision in the jungles of Guatemala, where Mayan ceremonial causeways trace the path of Venus across the sky. What's revolutionary isn't just the discoveries themselves, but how they're being made. Archaeoastronomers now use software like Stellarium to recreate ancient skies, accounting for Earth's shifting axis over millennia. A temple doorway in Malta that seems misaligned today might have framed the winter solstice sunrise perfectly 5,000 years ago. Even subtle details like the angle of a shadow cast by a single standing stone can reveal sophisticated calendar systems when analyzed with photogrammetry. The Nabta Playa stone circle in Egypt, once dismissed as a simple cattle enclosure, is now recognized as a Neolithic observatory tracking the summer solstice and monsoon seasons with eerie accuracy. The implications are profound. Sites like New Grange or Chichen Itza were once considered rare exceptions, elaborate one-offs in human history. But as technology surveys more ruins, a pattern emerges. From Peru's Chanquillo, with its 13 towers marking the sun's yearly journey, to China's Taosi Observatory, where rammed earth walls functioned as a solar meridian line, these weren't isolated feats. They were part of a global tapestry of sky-watching traditions, each culture interpreting the cosmos through its own lens, yet arriving at strikingly similar conclusions. Yet for all our advanced tools, some mysteries resist decoding. The purpose of Carnac's thousands of standing stones remains debated. Were they a colossal lunar calculator, a seismic predictor, or something else entirely? And why do so many ancient sites incorporate acoustic properties that amplify specific frequencies during celestial events? The more we learn, the clearer it becomes. These builders weren't just tracking stars. They were creating multisensory experiences where architecture, astronomy, and even sound converged into something transcendent. The future of archaeoastronomy lies at the intersection of disciplines. Chemists analyzing the metal content of Bronze Age artifacts have traced ore sources to specific meteor showers, hinting at cosmic origins for sacred objects. Geneticists studying Inuit oral traditions found star lore encoded in DNA markers, preserving navigation knowledge across generations. As satellite constellations blanket modern skies with light pollution, these ancient techniques honed over millennia of patient observation offer a humbling reminder. Our ancestors didn't just look up, they listened, measured, and inscribed the heavens into the very ground beneath their feet, leaving behind puzzles we're only beginning to piece together. Washington, D.C.'s street plan holds a secret most tourists miss when the sun sets on July 4th. It aligns perfectly with the National Mall, setting the entire city aglow in golden light. This isn't accidental urban planning. Pierre L'Enfant's original design for the Capitol in 1791 deliberately mirrored celestial patterns, with diagonal avenues named after states intersecting like constellations against a grid of stars. The Capitol building anchors the layout as Polaris would the night sky, while the Washington Monument's obelisk casts a shadow that traces the solstice like an ancient sundial. Across the Atlantic, the Louvre Pyramid in Paris reveals a similar kinship with the cosmos. Architect I.M. Pei positioned its glass panes so sunlight during the winter solstice creates a perfect geometric projection on the museum floor, echoing the pyramids of Giza's solar alignments. These modern marvels raise a tantalizing question: are today's architects consciously reviving ancient sky-watching traditions, or is there something deeper at play? Consider the United Nations headquarters in New York. Its General Assembly Hall rotates 15 degrees daily to track the sun's path, a feature inspired by indigenous solar calendars. Chicago's Willis Tower, formerly the Sears Tower, was engineered with corner notches that frame the equinox sunrise when viewed from specific points along the Chicago River. Even Dubai's Burj Khalifa, the world's tallest building, aligns its central axis with true north within a fraction of a degree, mirroring the precision of Babylonian ziggurats. The connections grow more intriguing when examined through history's lens. In the 1920s, astronomer Carl Jung collaborated with architect Hermann Sergel on plans for Atlantropa, a utopian city where skyscrapers would function as astronomical markers. Though never built, their blueprints influenced later designs like Berlin's Tempelhof Airport, whose runways align with the summer solstice sunrise. Meanwhile, Brazil's capital Brasilia, designed by Oscar Niemeyer in the 1950s, arranges its government buildings along an east-west axis mimicking the path of the Milky Way, a nod to indigenous Tupi-Guarani cosmology. Skeptics argue these alignments are coincidental, attributing them to aesthetic symmetry or practical lighting needs, but the evidence mounts when you consider symbolic intent. The Ground Zero Memorial in New York positions its twin reflecting pools so the sun pauses directly overhead at 10:28 a.m. on September 11th, the exact moment the South Tower fell. Singapore's Helix Bridge twists in a double helix formation that mirrors the structure of DNA, illuminated nightly by LED sequences timed to lunar phases. Whether through conscious homage or unconscious archetype, humanity keeps returning to celestial patterns as a language of meaning. Perhaps the answer lies beyond intention. Psychologists note that humans instinctively seek order in chaos, a trait called apophenia. The same mental wiring that let ancestors connect stars into constellations might drive modern architects to echo those shapes in steel and glass. Yet the persistence of these designs across cultures and eras suggests something more profound: that aligning with the cosmos isn't just a tradition, but a timeless expression of harmony. From the Capitol's starburst avenues to the Louvre's solstice spotlight, these structures whisper that even in our digital age, the stars still guide us not as gods or omens, but as silent partners in humanity's endless dance between earth and sky. The legacy of these forgotten architects lingers not just in their stone alignments, but in the radical way they saw the universe not as a distant void, but as a living tapestry woven into daily life. Consider how differently we engage with the sky today. We check smartphone weather apps while ancient priests charted monsoons by the Pleiades rising. We glance at digital calendars while Maya astronomers calculated Venus cycles across generations. This wasn't primitive science. It was a holistic philosophy where celestial rhythms dictated planting seasons, temple rituals, and even the timing of royal coronations. The Great Pyramid shafts pointing to Sirius weren't just architectural flourishes. They were portals linking pharaohs to the afterlife, proving that for these builders, astronomy wasn't a subject, it was the very language of existence. What's startling is how these cultures separated by oceans and millennia arrived at similar insights. The Navajo's Orion-inspired sand paintings, the Maori's navigational star lore, and the Hindu nakshatra system all reflect a shared understanding that human fate was written in stellar patterns. Modern physics confirms this intuition in unexpected ways. Quantum entanglement mirrors indigenous concepts of cosmic interconnectedness, while fractal geometry echoes the recursive patterns in Mayan temple designs. These parallels suggest the ancients weren't just stargazers, they were early systems thinkers, recognizing universal principles we're only now quantifying with equations. Yet their true genius lay in merging observation with meaning. Unlike modern astronomy's cold calculations, their celestial knowledge served a higher purpose. When Babylonian priests tracked Jupiter's retrograde motion, they saw the god Marduk altering earthly destinies. The Incas didn't just build solstice markers at Machu Picchu, they staged rituals where sunlight physically tethered the sun god in tie to earth. This fusion of empirical precision and sacred storytelling challenges our compartmentalized worldview. For them, a comet wasn't just ice and dust, it was a divine messenger demanding interpretation. The irony is that our technological prowess has cost us this cosmic intimacy. GPS satellites guide us flawlessly, yet few can identify Polaris. Telescopes peer billions of light years away, but urban light pollution obscures the Milky Way from a third of humanity. The Dogon's knowledge of Sirius B seems mystical until we realize their entire culture was structured around sustained sky observation, something our distraction-filled lives rarely permit. Perhaps their greatest lesson isn't about star charts but about attention. They remind us that wisdom emerges not just from data, but from patient, generations-long dialogue with the heavens. Reconnecting with this legacy doesn't require abandoning modernity. It's about synthesis. Citizen science projects now revive indigenous fireball tracking techniques to monitor meteor showers. Architects like Norman Foster designed solar-aligned buildings that reduce energy use, mirroring Angkor Wat's solar corridors. Even NASA consults Navajo elders about lunar missions, recognizing their descriptive lunar phase terminology surpasses clinical jargon. The past and present are beginning to orbit each other like binary stars, each illuminating the other's blind spots. The stones left by these architects are more than relics, they're invitations. When we stand where they stood, tracing solstice shadows or decoding petroglyphs, we're not just uncovering lost knowledge, we're rediscovering a part of ourselves, the part that once looked up and felt not small but connected. In an age of climate crises and space exploration, their holistic vision feels urgently relevant. They understood what we're relearning, that survival depends on seeing Earth not as a lonely outpost, but as a participant in something vast and wondrous. Their monuments whisper that the sky isn't just above us, it's within us, waiting to guide our next steps among the stars. The forgotten architects of the sky left behind more than just stone and shadow. They built a bridge between Earth and cosmos, one that we're still walking today. Their temples weren't just aligned to the stars, they were conversations with the universe, etched in geometry and light. Think of the Maya priest who carved Venus's cycle into a temple step, or the unknown builder who positioned New Grange's entrance to catch the solstice sun. These weren't arbitrary choices, They were acts of devotion, a way of saying, "We see you, and we remember." What's humbling is how these ancient sky watchers achieved such precision without satellites or silicon chips. The Dogon tracked Sirius B's orbit through oral tradition. The Polynesian navigators crossed oceans using star paths memorized in chants. The builders of Carnac arranged thousands of stones to mirror the moon's most subtle dance. Their tools were patience and perception, their data written not in bytes but in bone, stone, and story. In an age of algorithms, we've gained accuracy but lost something vital: the intimacy of knowing the sky as a lived experience, not just a dataset. Yet their legacy isn't locked in the past. Modern architects echo their vision, from Brazilia's Milky Way-inspired avenues to the solstice-aligned skylights of sustainable buildings. NASA consults Navajo elders on lunar missions, recognizing their descriptive language for moon phases surpasses clinical jargon. Even the search for extraterrestrial life draws on ancient star lore, as scientists scan the very constellations the Maya and Babylonians mapped for gods. The circle is closing, so tonight step outside. Let your eyes adjust to the dark. Trace Orion's belt or find the North Star, just as countless generations have before you. In that moment, you're not just an observer, you're part of an unbroken chain of wonder. The stones and stars still whisper their secrets, waiting for those willing to listen. And who knows, the next chapter in humanity's celestial story might begin with your gaze upward, rekindling a dialogue as old as the first campfire under an open sky. The architects may be forgotten, but their invitation endures. Look up, the cosmos is closer than you think. If this journey through time and space resonated with you, share your own sky stories below. Whether it's a childhood memory of spotting the Big Dipper or a recent moment of awe under the stars. And if you're craving more mysteries, tap that subscribe button for our next adventure into the unknown. Until then, keep wondering, keep exploring, and most of all, keep looking up. The universe has always been speaking. It's our turn to reply.